Okay, friends, we've talked about 1 bird, 2 birds. Now let's send Max in for 3. Okay, so this is flock number 3. And let's make the distribution for flock number 3. Okay, so X is the number of girls, which is what we're interested in. Okay. We want the P of X to correspond to the likelihood of each of these outcomes, and we want the sum of the probabilities to be 100%. That way we know we've done everything correctly. Okay, so with 3 birds, if I buy 3 birds, how many girls can I have in the flock? Well, I might get all roosters. Might. I might get 1 girl, I might get 2 girls, or I might get all 3 girls. As a person who wants eggs, I want that particular outcome. But I need to look at the rest of the outcomes as well to make sure I know how likely these things are, because the likelihoods of the other things tell me if I want to do something or not. And more on that to come, if we haven't already talked about it, which I think we will have already talked about it on Tuesday of this week. Sorry, this is weird because anyway, we'll talk more about it. So what's the probability? Well, applying this logic to all of these situations, I think we can see the likelihood of getting no girls at all is just going to be 0.1 cubed, because it's like extending the 2 chicken or the 2 bird synopsis to 3, or the situation to 3. It's a 10% chance each time. So in order to get 0 girls, that means I got to get a rooster on the first bird, and a rooster on the second, and a rooster on the third. And that makes sense if I want to get 3. And it also makes sense that that's extraordinarily hard to do. That's a 1 in 1,000 chance. So this is when you hear people complain. If they get 3 pullets and they're all boys, you're going to hear a complaint from the customer. But the thing about it is I've never heard of that happening. People buying exactly 3 birds and getting exactly 3 roosters. It's different if you buy 100 birds and get 3 roosters. Then you almost expect it. But to buy exactly 3 and to get exactly 3 is very unlikely, which means there's a problem with the 90%, 10% assumption, most likely. Similarly, 3 girls out of 3 birds would, again, it's a parallel kind of mathematical argument. It's 0.9 cubed, which would be, let's see, it's 0.81 times 9. I think it's 0.729 if I carried my ones correctly. 819. Yeah, 0.729. About a 73% chance, which means roughly 3/4 of the time I should get all girls if I buy 3 birds. Now, taking a macro view from this does make sense. Since 90% of the birds sexed are female, 3/4 of the time that I buy 3 of them, I should get all girls. So that means I've bought 12 total birds altogether, and 9 of those 12, which is 3 of the 4 times I've purchased 3, 9 of the 12 should be girls. That means in that last one, that 4th one, there's a chance, a pretty good chance of a boy. And if there's a 3/4 chance of all girls, there's about a 1/4 chance of the rest being boys. So what we know right now is this is 0.729, this is 0.001. Together, this is 73%. Together, that's 73%, right? 73%. So the challenge now lies in figuring out what numbers go here and here. What's the chance of 1 girl and 2 boys and 2 girls and 1 boy? Well, if we extend the logic on these, if there's a 0.1 chance for every boy and a 0.9 chance for every girl, I think we can multiplicatively, string these together. If you've got 1 girl, that means you also have 2 boys. So that means you're going to have a 0.9 and a 0.1 and a 0.1. I'm going to write them out like that just because I want to make sense. Okay? And for 2, that means you're going to have 2 0.9s and a 0.1. Okay, so far? The problem with this, as some of you may have already figured out, is watch the math. Let's see, 0.1 times 0.1 is 0.01 times 0.9 is 0.009. Cool so far? 0.9 times 0.9 is 0.81 times 0.1 is 0.081. Now, if you look at those numbers, 8.1% and 0.9%. Added together, that's 9%. That's 9%. 9% plus 73%, we're shy quite a few percentage points, yes? We knew, and these are right, and these have to be correct, there's only options there can possibly be, is 73%. That means this has to add up to 27%, but it only adds up to 9%. We're short quite a bit. Can anybody figure out why? You got it. We oversimplified. When we said 0.9, 0.1, 0.1, that means we made it so when Max went in and grabbed the first bird, that one was a girl. The problem is, that one doesn't have to be a girl. That one can be a boy, right? That one could be a boy, and the next one could be a girl. Or the first two could be boys, and the last one could be a girl. So there's actually, it's not as simple as just putting 0.9, 0.1, and 0.1. It's not as simple as that at all. There's actually two other options. Let's synopsize that and then come back to here.